Hello everyone, welcome to Algebra is King. This video is about quadratic functions, hopefully everything about quadratic functions, and some EOC practice, some things you need to know for sure for the end of year exam of any kind that includes quadratic. So first of all, this just shows you what makes it a quadratic function, right? If the highest exponent you see is a 2, that is what makes it a quadratic function. Right? Once it's a 3, it becomes a cubic function. This is quadratic functions. Don't confuse this with having a variable as the exponent, because if your variable is the exponent, that is exponential and does not make a U shape like this. It makes a curve. So let's look at this shape here. This shape, there's a name to it. That U shape that's created by a quadratic function is called parabola. Parabola. And that's just what you call the U shape that's created by a quadratic function. Right? Now, in terms of how many numbers or terms you have in the quadratic function, it can vary. It can be one number only in the equation, or it can be two terms, three terms. It can be as many terms as it needs to be, but if the highest exponent is 2, then it is quadratic. So let's get to this next page here. This is just the three formats and a bunch of examples below that you can look at just to make sure you know why they call it standard form versus factor form versus vertex form. So standard form, pretty simple here. No parentheses anywhere, right? Just a regular equation. Of course, you have to make sure it equals 0. That's why I put that in here and I didn't write it for all the other ones. It's important, right? It doesn't have to equal 0 to give you an equation, but you have to assume that it equals 0 when you want solutions, because solutions on quadratic functions are x-intercepts, right? So since the x-intercepts always have a y value of 0, and those are the solutions, right? To get solutions, you need to make it equal to 0. So there are different ways to find those values. We'll talk about that later, but let's just look at some of these examples, right? Over here, the number touching x squared is 3, the number touching the x is 5, and the constant at the end is negative 10. Now those values are what you call A, B, and C. So whatever number ends up touching the x squared, the coefficient that touches x squared, is going to be your A value, right? You want to put it in this order: biggest exponent to smallest, constant always at the end. And of course, make sure it equal to 0 before you start calling anything A, B, or C. All right? This one here you're going to see a couple times over and over, because anything with a negative 16 in the front deals with gravity, because gravity pulls everything down to the ground at the same with the same force, no matter what the weight is to it, no matter what the density of the mass is. So that negative 16 is a common number. So we'll get back to that later on some of these examples. Let's keep it going to factored form. So factored form, if you notice, is the first one we see with a minus. In this case, two minuses in the format. So that's there for a reason, right? I didn't have to put it, but I get to explain two things at once. Factoring a quadratic function puts it in this format, and using the zero product property later gets you solutions using those factors. Those solutions, if you notice down here, are not negative. So because the format has a minus, you know the sign's always going to be different as a solution. So you'll notice that that happens later on with actual numbers. So you could just think about P and Q as the numbers that multiply to give you the C value, but add or subtract to give you the B value. So let's use this one as an example because it has the A, B, and C. So numbers that multiply to give you C, that add or subtract to give you B. Now, do they have to add to give you the number or subtract to give you the number? We'll talk about that when we do factoring. All right, here's some examples down here. I put y equals for some. I put sum equal to 0. It is the same process, right? There's no difference here. Everything you see here is the same. You just have to make it equal to 0. So if you're going to actually solve something, this is a 0. And you do the same process. So the reason why these uh, different formats exist really is to show you different information, right? So on the first one, before we get to vertex form, which is what we're starting with, let's kind of explain the first two and what they show. In standard form, you can see the A, the B, and the C, and you can also see the y-intercept because the y-intercept is C. That number, that constant, will always be your y-intercept. Just like in linear equations, the constant is the y-intercept. So let's move it on to the right side here. On the right side, it is vertex form. Now again, in this case, you have a negative in the format. That tells you there's a sign change. When you're going to actually tell me what the vertex is, you got to make sure you change the sign of this x value. Because h is the x value of your vertex, k is the y value of your vertex. So we'll talk a little bit more about h and k later on, but just understand that h as a vertex x coordinate is not the same sign as it was in a vertex form equation. It's going to change signs. All right, here's some examples down here before we move on to the next page of things that are in vertex form. And of course, what is visible in vertex form? The vertex, which gives you a lot of information. You're going to see that later on. The vertex tells you the x and y of the x and y coordinate of the vertex, which gives you your axis of symmetry down that U, and it gives you your minimum or maximum. So let's get into that a little bit later. Of course, here on the middle, I don't know if we remember talking about it, but just in case before I switch pages, this gives you the x-intercepts. If you see factored form, you can look at it and tell me what the x-intercepts are in most cases. And of course, you can see A in the front on both of these, but you can't see B and C. So let's get to the next page. All right, this is not just definitions here, vocabulary terms. These are things you need to know, right? Might be questions directly asked about this because they're gonna ask you about characteristics of quadratic functions. You need to know that. So this is a pretty simple one here. If the leading coefficient, leading means it's in the front, and we know A is the number that touches x squared, which belongs in the front in a quadratic equation. Let me just finish it off there. So if A, the number in the front, is a positive, then the parabola opens up like a smile. If A is negative, it opens down. Now, what does that really change? That changes this value? No, it does not. It just changes whether you call that a minimum or a maximum. But the calculation solving for those spots is the same throughout. So this is just noticing if it's going to open up or down in case you get a multiple choice question and both values touch your vertex. Right? Both graphs touch your same vertex. How do you break that tie? You're going to look at the leading coefficient. If it opens upwards, then you know it's positive in the front. If it opens downwards, it's negative in the front. And then down here is an image for the right side that kind of explains it. If the A value increases, the graph gets more narrow. If the A value decreases, the graph gets wider because it goes up slower. Narrow because it goes up faster, wider because it increases slower. So let's take a look at it before we move on to the next page here. The parent function for quadratic is this one right here. Just y equals x squared. They put f of x equals x squared. F of x is the same as saying y. Same thing. So either way, right, that's the parent function. Right, that one has only an a value of 1, b is 0, and c is 0. So that's like your basic parent function for quadratic here, for standard form quadratic. So now look at what happens when the number is bigger. If the number gets bigger, instead of being a 1 in the front, it's a 2. The graph gets more narrow. Look at this green line. It goes up faster, so it gets skinnier or more narrow. And now, in reverse, down here, it's a decimal that's smaller than 1, so it got smaller, and the graph goes up slower, so it becomes wider. Simple concept. Don't forget it. All right, now intervals, right? A lot of you right now, I ask you, what's an interval? You won't say, you won't be able to tell me what it is. But if I ask you a question that involves an interval, you can answer it immediately, right? If I tell you this graph starts to increase after what number, right? You would tell me after 2, right? If I say, is the graph increasing or decreasing between 2 and 5? You would tell me it's increasing here between 2 and 5, right? That's what an interval is, a section of x values. So between 2 and 5, what happens to this graph, right? That's what they're asking here. So pretty simple concept, right? Let's get these 2 questions answered and move it along, right? Which interval shows the graph decreasing, right? So in this case, it's not going to be between 2 numbers, right? It's just going to be an inequality because it's decreasing from the beginning all the way until it gets to what value? It's decreasing all the way until it gets to this value right here, which is your 2. They're labeling it for you. So we know it. Once it's lower than 2, that's when it's decreasing. Now what happens after 2 when numbers get greater? It starts to increase. So when is it increasing? When x is greater than 2. So notice that 2 is your x value of your vertex, which is what we call h. So like I said, vertex gives you a lot of information in a lot of cases. It helps with everything. If you know that the vertex gives you a lot of information, it tells you when it starts to change direction. It tells you a lot of information you're going to see along the line here on this same explanation I'm going to give you today. All right, so this part, I'm not going to explain the stuff on the right. All right, for the most part, I just want to look at this image and maybe take a look at the last 2 pages. Feel free to pause it and copy this down or look at it for sure, because this information is important and we're going to use it later on. That's why I'm not going to do this work at the moment. So let's just look at this image that we have over here. For this image, I label everything for you. On the next few pages, I just explain everything in more detail. All right, but this is pretty self-explanatory because it's a graph. In a graph, you can get everything you need pretty much immediately. So let's start with x-intercepts, which is probably the most important here in terms of quadratic functions. Because when it comes to word problems, a lot of them are going to be about hitting the ground, when does it touch the water, how many seconds until it reaches the floor. Anything floor, ground, water is your x-axis in real life, because real life has no negative values. So really you're only looking at this side of the graph if it was a word problem. So again, let's start with x-intercepts. That's just where it crosses the x-axis. Self-explanatory at this point. Y-intercept, that's where it touches the y-axis right here. Now vertex is the x and y coordinate like we mentioned before. We call it HK just because it's a special point. It's not just any point on the graph. That's the tip of your graph, which gives you a lot of information. So we label it HK so we know it's not just any x and y. It's our x and y of our vertex. But at the end of the day, it's still just an x and a y. So in this case, what is that value? Just to make sure we know what we're talking about here. 1 comma negative 4 is where that lands. 1 on the x, negative 4 on the y. That's where the point is. So that's your vertex, which means your axis of symmetry is x equals 1, the x value of your vertex, because that is that orange line that's not really there. It's an imaginary line that you're drawing just to see where the axis of symmetry is, where this U shape gets cut directly in half and creates 2 symmetrical parts. So that's important too for graphing, to locate that immediately, where your axis of symmetry is. And of course, make sure it has an x and an equal sign whenever you're asked axis of symmetry, because at the end of the day, to be a line, you need an equal sign. So if I say what is the minimum or maximum, you could just tell me it's negative 4 as your minimum, right? That's pretty simple. I didn't have to put y equals negative 4 there because the minimum is negative 4. But the axis of symmetry is a special situation where you have to put x equals 1, which is the equation for a vertical line. So just don't forget the x on this. Let's keep it going here. Again, you feel free to pause on these pages just to like look at what I wrote, but I'm not going to go through the image again because we explained it all on that first image. This is where I want to slow down a little bit because it's where we're starting in terms of the practice questions we're doing. All right, I want to start with this because this is how you calculate your h value, which is your x value of the vertex. Once you plug it in for the x's in your equation, then you find your k value, right, which is the y value of the vertex. Now, when it's a graph, you don't need this, right? You have the graph, you can see where it is. But when you have an equation in standard form, these are the two steps to find your vertex. All right, let's keep it moving here. This is another important page. The last two, vertex and intercepts, x-intercepts are the most important. So x-intercept, first of all, right, is on a graph because there's no context to it. All right, same thing as solutions, really. But roots and zeros sounds kind of funny, right? Zeros I kind of explained. It has to equal 0 because it's an x-intercept, so they call them zeros. Solutions are what the value of x is when you're solving this, and x happens to be an x-intercept. And roots come from the ground, your x-axis in real life. So all these words mean the same thing, right? They mean the same thing. If you're asked to find either one of these four, it's the same process. You have to do one of these three processes to find your values. Which one should you use? It depends on what you're given. Right? If you have an equation in standard form like this, right, then quadratic formula will work better than zero product property because we don't know if this is factorable. If you try to factor it, spend 5 minutes factoring and it's not factorable, then you will fall back to quadratic formula anyways. And this is not something you have to memorize anymore. It's in your formula sheet. So you just have to remember, first of all, to plug in the numbers in the correct spots. And I would recommend using my same technique to plug those numbers in. I like to put an empty space before I write any numbers in here, wherever I see an A, B, or C, to avoid mistakes with the sign. So once I do that, now I put the numbers in. So now my A, B, and C, right, go where you see A, B, and C. So in this equation, for example, A is 2, B is 6, C is 3. The first numbers here are B's. Let's put the 6 in there and there. Your A values go next. 2 here, 2 on the bottom, that's where the A is. And C is always the last number in the radical, which is 3. So now, the first part here and the bottom part simplify themselves pretty easily, right? And then you have to simplify the radical part. Don't forget the steps here. First you do your exponent. 6 to the second power is 36. Very important, you do not do minus 4 right now. If you do that, you're skipping multiplication. You always follow order of operation. So these three numbers get multiplied. In this case, negative 4 times 2 is negative 8, times 3 is negative 24. Now whatever value you get here, right, in this case it's square root of 8, you put it right here. Now, most of the time, you're going to get a clean number there, like square root of 16. You're going to get 4, and you put the number 4 in here, right? But even if it gives you square root of 8, that just means your answer is going to be a decimal, and they'll tell you to round it to the nearest 10th, 100th, or 1000th, right? So let's clean this up and just use a regular number just to finish it off and show you how you get an actual solution from this. So let's say our value was 12 here. Now, first solution, you get it by using the plus sign here. Negative 6 plus 12 is 6, divided by 4 is just 3 over 2, or 1.5. So if they have fractions or they want a fraction, leave it as 3 over 2. If they want a decimal, it's 1.5. Now, we get the second answer by using the minus. So negative 6 minus 12 is negative 18. Over 4 gives you negative 9 over 2, or negative 4.5. So those are the two solutions, and we use a quadratic formula to get there. Right? Now the good thing about quadratic formula, it always works. right? Always works, it never fails. With factoring, it has to be factorable. But with quadratic formula, you can always use it. And you can also backtrack your answers into factors. So for example, let's do some easy answers here like x equals 2 and x equals 5. If I have solutions that are 2 and 5, that means as a factor it was x minus 2 and x minus 5. So I already have most of my equation. The only thing I would have to calculate is my a value that goes in the front here, and that will do on the second to last question today. Alright. Same thing with these fractions. If you're trying to backtrack these fractions into solutions, let's just do 3 over 2, which was our solution over there. Negative 9 over 2 over there. So if you want to backtrack these into factors, right, it's the same process. Just you divide 3 divided by 2 is our answer, 3 over 2. So dividing by 2 is always the last step, division. So what you need to do is change the sign of the number on top and make sure the 2 touches your x. And now you have the factor even though you didn't really factor it. You use quadratic formula. So if you, in case I show you factoring and during the test you blank out, you forget to factor or forget how to factor, there's a way out. Go to your formula sheet, look at the quadratic formula, solve. Once you get to answers, put them into parentheses, changing the sign, and you're going to have the equation once you solve for A. Alright, so let's start now with some practice questions. Alright, no more definitions, the rest is just practice questions. So first of all, you're going to need to know how to change from one format to another, right? For now, let's just start with this one, because vertex form is the first practice questions we're going to work on here, and I want to make sure that you can practice it enough over there. So over here, right, a lot of students I see trying to distribute here. No way. You do not distribute. If you distribute, you're skipping exponent, and you always follow order of operation. So you have to expand x plus 3 to the second power to x plus 3 times x plus 3. Right? Then you can bring down your 2 where it's at and the plus 2 where it's at. Now this is the easier situation to simplify. You can either distribute the 2 now, right? Or as a second step. I would recommend you do it as a second step because there's going to be like terms to collect. Smaller the number, the better. So x times x is x to the second power. When you add those 1 exponents they all have, x times 3 is positive 3x. Now, 3 times x, positive 3x again. 3 times 3, positive 9. Once you collect like terms in the middle, you end up with a middle term of 6x. Now you're ready to multiply these values by 2. Don't forget, only what is next to it is going to be multiplied by 2. This 2 over here is the last thing you're going to do. It's not going to be multiplied by this 2 in the front. So when you multiply these 3 terms by 2, you get 2x squared plus 12x plus 18 plus 2. Now you can put together these like terms and you'll have your final equation. So your final equation is going to be 2x squared plus 12x plus 20. And of course, if they make you write it in terms of y and x, you write y equals. If they put a y equals with a box for you to put the expression in, then you just put this piece in here. Alright, so we'll get to the other 3 as we work on those questions. Let's get started here. So these equations are all in vertex form, right? They're called vertex form because you can see the vertex. The number that's right here is your h value, which is 3. Notice if in here you see x minus 3, your h value is positive 3 because of that minus we talked about at the beginning. And then this value, your k does not have a minus, so that does not change signs. That just comes down as 4. Make sense? So now we know the vertex is 3, 4. Now what does that really give us? Axis of symmetry, which is x equals 3. See what else it gives us. In this case, the leading coefficient is negative, so it opens down like this. So we have a maximum on our hands. The maximum is our y value of the vertex, 4. We can see it's 4 over here. K is your maximum or minimum. And now your a value, we know is negative 1 because it's the minus touching the front there. What else can we get from it? We can't see the zeros yet. We would have to factor to get the zeros. And then the standard form equation is what we did on the previous page. We converted vertex form to standard form. But now look on a graph. You can find the same values and the x-intercepts if you have a graph. X-intercepts are 1 and 5, which means my factors were x plus, x minus 1, x minus 5, but we're not doing factor form here. Our axis of symmetry clearly visible here. It's along the 3, so x equals 3 was our axis of symmetry up here. Our maximum, our highest y value, 4. Everything's here on a graph. So on an equation with vertex form, it's the same thing as a graph. You get almost everything except x-intercepts, which you don't need when you're answering questions about a vertex, axis of symmetry, or minimum or maximum. It's a different location on a graph. They're not going to ask you about the ground when they're asking you about the highest spot. That's the opposite. Alright, so let's get to this right here. This is important. Alright, you can use these other questions to practice, right? I will mention here, if there's no k, k is 0. So don't think there's no minimum or maximum. It would be a maximum of 0 or a minimum of 0. So now over here, right, I just want to talk about the only possible questions they can ask you on quadratic functions, right? If you look at the shape, a straight line, a lot more questions to be asked because it goes on forever. But in a word problem, right, or a graph like this that only shows you the L, right, that positive portion of the graph, there's only so many questions they can ask about. They can probably ask you about the x-intercepts. I'm going to put intercepts because sometimes it touches once, sometimes it touches twice, sometimes it never touches. Y-intercepts. In this case, one y-intercept, right? The u is not going to turn back around, hit the y again. Which is, in this case, don't forget the words that mean the same. Zeros, solutions, all right, y-intercept, self-explanatory. They can also ask you, right, where the symmetry is, where the axis of symmetry is. And they could also ask you about the highest point, which is your maximum or your minimum. All right, so I want to talk about these same things in terms of a word problem. All right, we can use this one right here as an example, right? And usually your x-axis is time or horizontal distance. Either way, it's a horizontal x value because it's horizontal. So this is pretty simple, right? They could ask you about the y-intercept over here, which is your starting point. So y-intercept, keywords that'll tell you that's what they're asking about, right? Are initial value, starting point of the situation, right? It could be jumping off a diving board, it could be throwing a football, right? If you're throwing a ball, you release it around your head. So if they're asking about the y-intercept, they're going to ask about someone's height. Or if it's a diving board, they'll ask for the height of the diving board. Either way, that is your starting point of the situation. So if you have an equation in standard form, you know the y-intercept is c, so you can tell how tall the person is if it's in standard form, or how tall a diving board if it's in standard form. All right, what else can they ask? They can ask us about our x-intercept. What's x-intercept in real life? The ground. So any question that says how many seconds until it hits the ground, I'm going to put here seconds to make sure you know it's an x value. Your ground is your 0y value. So they're asking about how many seconds till it gets to that, the ground. Same thing with water. If you're throwing something above water, you can consider the water your x-axis, or floor. Same concept. All right. So now let's look here at vertex questions, because really, there's only three things: x-intercept, y-intercept, and vertex. But vertex is broken up to h and k, which provide different information. So they could ask you for these two things. They could say highest point, period, or they can say how many seconds to reach the highest point. Right? Both those are two different questions, right? But they both deal with your vertex because your x value is time. So the seconds question, time, has to be your axis of symmetry value. So in this case, your axis of symmetry, let's say, is 1.8. That would be your x equals 1.8 is if they ask for axis of symmetry. In this case, it's a real world scenario. So you cannot put that, you just put 1.8 seconds. It's just an example, right? It would be more exact once you're actually getting the question. And now highest point is a y value, feet, height, right? Highest point. So you just look at the highest y value. In this case, is 45. 45 is your highest point or your maximum. So be careful with that because they could use the word maximum in both cases, but they might be asking for x to get to the max, or they might just be asking for the max. And same applies for minimum. All right, so let's get started here. You can look at these later, right? Just to kind of test yourself, see what they're asking. Are they asking for the x-intercept, y-intercept? So let's get straight into the work. So here, find the axis of symmetry, and these equations are in standard form. So this is what I first told you that we're going to begin with on practice questions. It takes a little bit of work, but it's not difficult. You just have to remember two things: how to find h and how to find k. To find h, it's negative b over 2 times a. To find k, you plug in h for x. So in this case, my a is 3, b negative 6, c is negative 2. So I just have to plug in my b where it's at with the negative next to it already. So in this case, it's negative 6 over 2 times the a value, which is 3. So that gives you positive 6 over positive 6, which equals 1. That is your axis of symmetry, but you have to put it in equation format. X equals 1. Don't forget the x. Now to find your maximum or minimum, in this case the number in the front is positive, so it opens up. So this would be a minimum down here. So we're going to say minimum, and to calculate it, you plug in for the x values. So 3 parentheses squared plus negative 6 parentheses minus 2. Notice I always do that when I plug in numbers to avoid mistakes with the sign. Really to train you guys to not make mistakes with the sign. So far so good. So let's plug in our values. 1 in both spots because those are your x values. Now follow order of operation. You have to make sure you do the exponent first, which gives you 1. Then you multiply by your 3. Same thing here. You have to multiply these numbers. Don't try to subtract. Multiply these numbers. And it gives you negative 6. So we have 3 minus 6 so far. Bring down your minus 2. Now you can subtract from left to right and get your value as negative 5. So what is negative 5 specifically? It is my minimum. How many seconds did it take to get to the minimum? 1, if that was a word problem. So again, this here can be a decimal answer. So be careful with that because a lot of people think they did something wrong because they did not get a clean answer. So let me show you one that gives you a decimal here. I'm just making up these numbers. So negative b over 2 times a. In this case, you get 13 over 2, which is 6.5. So x equals 6.5. That is a perfectly reasonable axis of symmetry. If it's a 0.5, you're usually fine. All right, once it gets to a crazy decimal, you probably did something wrong. All right, let's keep it going here. So now these questions look complicated, right? They are not, but they're good to review because we kind of talked about it in the vocabulary section, but now you can see it on an actual graph and on a question itself. So vertex, right, is the x and y coordinate. Tip of that U, the coordinates for that spot are 1, -1. That's where it's located on the graph where I marked it. Axis of symmetry is x equals 1 because we have it here. Our axis of symmetry is the x value. Domain is all possible x values, right? Since these arrows are here, you know it goes to the left and to the right forever. So the domain is all real numbers. 9 times out of 10, domain is all real numbers. Unless it's a word problem, then it's all real numbers greater than 0. Alright? Range, same concept. Because you have your maximum y value, then you know your range. Just write it in an inequality format. Y is less than or equal to -1. Now, why did I put less than instead of greater than? Because our graph is below that line. So all the y values have to be below that number. Make sense? On these questions, make sure you know, right? If you get some questions like this, you can repeat an answer. So if you use like the number 2 for something, the 2 will pop up again back down there. So just keep that in mind, right? Some of these questions you can repeat an answer. So don't just think every number has to be different. If our vertex was 1, 1, you'd have to grab the 1 twice. Right? So here you can use this one as like a practice question, right? But it's the same concept as we talked about in the front. I'll just kind of brush up on it, right? Increasing and decreasing. So they're saying the range is less than or equal to -1. So you know it has to be a graph that opens down. So already we know that's the answer because that's the only graph that opens down. But let's verify it with the next piece of information that must be true. It's decreasing when x is greater than 2. What happens? Oh, -2. What happens after, in this direction, after -2? It's going down. It's decreasing. Perfect. And before that, it was increasing to get to that value. So before that, -2 value is increasing. All right. On this question, really, I want to focus on the chart here. Right. Yes, you can just plug in numbers, these numbers here, right, and see if they match with the points that touch the graph. Right. But it's a lot simpler to do what I'm going to do right now. Look for the numbers that repeat, because since a graph goes up and down, it's symmetrical. A lot of times you got numbers that repeat here. So if you have numbers that repeat, right, then you look up at the x values. There's only one number that's directly in the middle of -4 and -2, and that's exactly -3. That would be the midpoint between those. So that is your axis of symmetry, which means 16 is your vertex. So even though they don't say it's a vertex, you know this is the vertex. And now you can just look at which one touches the graph on that spot. -3, 16, this one. In this case, there's no other graph that touches that spot. But what if there was another one that touched it, but it opened up, right? Then you have to make sure you pick the correct graph by looking at if it started to increase or decrease. So at first, it's increasing, then it's decreasing in y values. That tells you it opens up, goes up, and then it comes down. So that's how you break a tie if you need to break a tie. All right, this question, I got a lot of questions in class about this one right here. So if you have the equation, it is so simple to answer any question about anything really. In this case, a graph. Graph is wonderful because you can quickly see which one touches the correct spot. And that's what you should do in this case, right? The 0, 0 y-intercept is the same on all of them. That's what I would start looking at. In case they're different, we can eliminate choices that way. But in this case, they're the same. So we just got to plug in a number, an easy one, and see which one touches the correct value, right? So let's just use 10 or 20. Let's just try 10. Of course, as usual, order of operation, always exponent first, which gives you 100. Now you can multiply by your 0.025 negative, and you get negative 2.5, which means a point that touches our line on the graph must be 10, comma, negative 2.5, because I plugged in that x and it gave me that y. Now let's look at the graphs. This one touches 10, comma, negative 25, not negative 2.5. This one touches 10, comma, looks like negative 50. This one touches right between 5 and 0, negative, which is negative 2.5, our answer. And this one touches, barely gets off the 0, so it's a small, small decimal. So this is our answer. The one that touches the point that we made just by plugging in a 10 to the second power and we multiplied it. So don't overthink these long questions, right? If they give you graphs, it is an easy question. All right, this is just the formats again. We already went through these examples, so let's go to this right here. So the reason why I'm showing you a non-quadratic function here is because to graph quadratic functions in standard form that have a number bigger than 1 in the front, you have to use different methods. One of the methods is breaking into 4 terms and using factoring of polynomials like what I'm going to show you up top to answer them. So let's get to it now. First I'll show you these 3 and 2 term ones up here, and they use that same logic for the other ones. All right. First of all, the order needs to be correct. Biggest exponent to smallest. So the top ones are correct. Over here you see that something needs to be moved around for you to start working on it. All right, so let's start by this one. I'll do the long way at the beginning, but you can get the concept, right? What numbers go into 5, 10, and 20? The biggest common factor, not just any factor, right? 5, 10, 20. I know we all know it's 5, but it's good to show you the process in case the numbers get large. You only got to break down the smallest number, but you start testing out the biggest factor. In this case, 5 goes into both of them. It's got to be 5. So here you're going to put 5 times 1 right below the 5 and put 6 x's, because x to the 6th power is x times x times x 6 times. Now the middle term is negative 10x to the 5th, so it's 5 times negative 2. This one only has 5 x's. And now positive 20 over here is 5 times 4, and you have 4 x's. So what do they have in common? They all have a 5 at least, right? And they all have 4 x's in common. No more than that, because there's not enough to have more than that in common. This only has 4. So if you think about it, you're only taking out the smallest amount of variable they have, because that's what would be in common. And now we're ready to put the answer for this equation here. Let me move this out of the way. So whatever you took out is your greatest common factor, which was 5 and 4 x's. So make sure you put 5x to the 4th power. And now whatever you didn't take out is still in there. On the first term, we left an x squared in there. I know there's a 1, but a 1 next to a variable, you don't write it. On the second term, we left a negative 2 and 1x. And on the last term, we only left a positive 4. So this is how you factor polynomials. All right, we'll get to factoring quadratic functions on the next few pages. And now this one right here, probably the most important one, because it deals with gravity. And because it reminds us that if the leading coefficient is negative, you have to factor out a negative. So when you do this breakdown that we did here, you're going to do it with a negative value. And don't forget, not just any number that goes into both of these, the greatest common factor. So in this case, it's negative 16, 2 t's, negative 16, because you need to match it to take it out, times negative 4. Because a negative times a negative is a positive. So you must take out a negative if the leading coefficient, the one in the front, is negative. If A is negative. So now this one only has 1 t. What do they have in common? Negative 16 and 1 t. So that's what comes out of your parentheses. And now what's left is t minus 4. Now later on you're going to see getting two solutions from this is simple. Make them equal to 0, which is the zero product property, and solve them both. In this case, you're going to divide by negative 16, and you get one answer as 0. Here's a little hint for you. Anytime a variable touches the parentheses on a quadratic, one of the answers must be 0. And then the other one, if you add 4 to both sides, you get t equals 4. So if this was a word problem, the 0 would be invalid because nothing can go up in the air and hit the ground in 0 seconds. But 4 is a legitimate answer. Just plug this in before I run out of battery. Alright, so now I'm going to clear this up and we're going to practice these questions on the bottom here. Alright, here we go. Alright, so first of all, let's do these two questions. You can leave the third one for your try it now question. So here, first you have to order it from biggest exponent to smallest. So 2s to the third plus 3s to the second plus 18s. The constant is always at the end. So plus 27 over here. So now, if you have 4 terms, right, you break it in half, include the sign with the 18 because that belongs to the 18. And now, over here, 2 and 3 have no number in common, but they do have s's in common. They both have 2 s's in common. So you can take out s to the second power, and that leaves you with 2s plus 3. Remember, the goal here is to match your parentheses on the right side now. So 18 and 27, the greatest common factor is 9. No letters in common because the 27 is a constant. So 9 comes out of your parentheses, and that leaves you with 2s plus 3. Our parentheses match here. So now we're ready for the answer. 2s plus 3 in one of these, and the 2 pieces you took out in the other. Now be careful because sometimes these questions end up with a minus here. If there's a minus here, that's a difference of squares, so it has to turn into 2 more parentheses, which is going to happen on the next one. So here, let's break it down. Only 2 b's in common, and you're left with b minus 5. Now this side, leading coefficient is negative, so you have to take out a negative 4, and you're left with b minus 5. If you forget this, you're going to end up getting b plus 5 and think you're wrong. So make sure you take out a negative if the front number is negative when you're factoring. Now the repeat goes in one of these, the 2 pieces go in the other. And now we will review difference of squares a little bit later on when we do factoring. But just so you know, square root the number. In the front you just have a b squared, so you know it's b plus and b minus for both of these because the middle number is not there. And then square root of 4 is 2. Now later on when we do factoring, I'll explain in more detail why this works out like that. So now let's get to some factoring trinomials. So it's pretty simple. If you use my method, I think, right, my order of operation, so to speak. So first, you should do the signs. It makes things a lot easier. So if the last number is positive, the signs are the same. Same as what? Same as the middle. So in this case, plus plus. Let's skip over to the second question just to do the signs. Last number is positive. In this case, it's minus minus because the middle is minus. Notice the signs are not different on these because the last number is positive. On this one, the last number is negative. That just means the signs are different. Now, how does that change things? That just means that you're looking for factors that multiply to give you 10, but that add up to give you the middle term, which is 7. Clearly, the numbers are 5 and 2. Put your x on both sides, 5 and a 2. You just factored it. Now, if you want solutions to that, you would have to make them equal to 0 and solve it, or just remember that the sign changes on solutions and you have a -5 and a -2 solution. Alright, same thing on the next one, so we're just going to move it along to a subtraction question here. So let's do these two. So here the signs are different on both of these because the last number is negative. Now these are simple, more easier than bigger coefficients in the front because when it's an x squared, you know it's just an x on both sides. Once we get to bigger numbers, right, it changes things. And we haven't even looked for a common factor because these are all ones in the front. You can't take out a common factor if the only factor is 1. So once we get to these bottom two, you're going to see you have to factor out the greatest common factor before you even do this stuff. So now let's start here. 10 could be 10 times 1 or 5 times 2. In this case, the numbers need to multiply to give you 10 but subtract to give you 9. So that has to be 10 and 1. Now make sure you remember your subtraction rule. You subtract and keep the sign of the bigger number. So you got to make sure your middle sign matches with your bigger number. So put the 10 on the plus and the 1 on the minus. Same concept here on the next one. 7 times 6 subtracts to equal 1 and multiplies to give you 42. So now, since the middle is positive, put your 7 where the pluses and your 6 where the minuses. That's it. You factored all these expressions. And then these down here, it's worth mentioning, you have to take out the common factor first. So where you're going to actually factor is a lot smaller values than you thought. So you're just going to factor x squared plus 5x plus 6. Just don't forget to bring down your 2 in your answer. So here the signs are the same as the middle because the last number is positive. So plus plus with the x in the front. And now 6 times 1 and 3 times 2 is a tricky situation here because these numbers both can give you 5. But when the signs are the same, they need to add to give you 5. So it has to be 3 and 2. If this was a different sign situation, it had to be 6 and 1. Alright. So now we get to this method here. This way of factoring numbers that are greater than 1 in the front. The a value bigger than 1. If it's bigger than 1, even after you take out the common factor, then you have to use a different method to solve it. The other method is just not going to work. But let's look back at the other method, right? We broke down 10. But really what you're supposed to break down is a times c. A is 1 here, c is 10. 1 times 10 is just 10. But we don't even think about it because it's an x squared in the front. We know it's the easy ones. But once you get to these questions, right, the correct way to do it, the way the book teaches you to do it, is to multiply 6 times 10, which is 60, and look for factors that multiply to give you 60, but can add up to give you 19. So you can try, 2 times 30. I know that the answer is 15 times 4, right, because that gives you 19. But let's say you don't know your factors for 60, right, but you do know that 10 times 6 is 60. Now you can use numbers that make up these numbers to try. So 5 times 2, let's try 5, right? 2 times 3, let's try a 3. 3 times 5 is 15, let's try a 15. 15 works. So instead of wasting time when the numbers get large and figuring out the factor, right? It might be easier just to look at the one you know and use those values. So we know it's going to be 15 and 4, right? So what they want you to do is change 19x to be a 4x plus a 15x instead of what it is over there, which is the same thing because when you collect like terms, it gives you 19x. It's equivalent. But now we can use grouping. What do these two numbers have in common? They're both divisible by 2, and they both have an x. And now what's left in there would be x plus 2. Now over here, 15 and 10 are both divisible by 5. What you're left there is 3x. I forgot the 3 here. 3x plus 2. Now, these match, so they go in 1. And the second one is the two pieces you took out, which is 2x and a positive 5. So that's the way the book teaches you, right? The correct way to do it. I use a different method sometimes, depending on the question, right? I really like the method I use. Now, if you like this method, no problem. Right? I'm not here to judge your process. I want to make sure you know how to do it. If this is the method you feel comfortable with, then please do it this way. But know that all these other questions I want to do quicker, right, to show you. And I would recommend this method because it leads to less mistakes, in my opinion. So break down the first and the last number vertically. So 3x times 2x like this. And now break down the 10 over here. 10 could be 5 times 2 or 10 times 1. You got to try 1 first. So I'm going to try 5 and 2. 5 and 2. Now, just in case, right, I'm going to put 2 up here, 5 here, because the numbers might be correct, but in the wrong order. So now let's do the signs. If the last number is positive, the signs are the same as the middle, so we know these two are positive. Now, cross multiply and see if you get positive 19. If you cross multiply here, you get 6x plus 10x, which gives you 16x. That does not match our middle number, so that means it's 2 on top, 5 on the bottom. 3 times 5 is 15. 2 times 2 is 4. That definitely gives you 19x. Once you have the correct middle number with the correct sign and everything, right, then you just put your answers in their spots. The top part goes in one binomial. That's 3x plus 2. The bottom part goes in the other. Remember, the order doesn't matter. What matters is the sign on each number. Alright, now let's do one more of these because this is definitely going to be worth a lot of points, factoring bigger quadratic functions like this. So first of all, 4 in the front could be broken down to 2x times 2x there, or it could be 4x times 1x. Let me show you something that'll save you some time on questions that have a 4 in the front like this. The number in the middle is 31. If you have 2x and 2x as factors, you must get two even numbers. And two even numbers together have to be even when you subtract or add them. So if you see this number as an odd number, don't use 2 and 2. It has to be 4 and 1. So 4x times 1x, 21 is 7 times 3 or 3 times 7. Now we know the signs have to be the same as the middle because the last number is positive. And now let's cross multiply. This one gives me negative 12 and 7, negative 7, which doesn't work. So we know it's going to be the other way around. Negative 7 times 4. 1 times negative 3. Together, that's negative 31x. We have the correct middle number and sign. So we're ready for the answer at that point. The top part is 4x and a minus 3 over there. And the bottom part is 1x and a minus 7. Those are your factors. I recommend using this method. It's up to you, right? More work, but if it leads to correct answers, I don't mind. I can grade it either way. Alright, so now this page seems like it's harder because it's called special cases, but it's actually easier. So let's go back to polynomial multiplication here so you can understand where these come from. Usually you have 3 terms in a trinomial, right? As long as the numbers are not exactly the same number with a different sign. Look what happens here. If the numbers are identical, but one of them is negative and one of them is positive, the middle term will always give you 0, which means the middle term disappears. That's a special case. We call that difference of squares, because the first and last number are perfect squares. 1x squared is perfect, 16 is perfect because it's 4 times 4, and difference means minus. So if you see a minus in the middle and two perfect squares, all you have to do is put your answer. Square root of 1x squared is 1x, square root of 49 is 7, and make the signs different. And you factored it. Now over here, take out the common factor first, and now we have a difference of squares. So the square root of x squared is x, make the signs different, square root of 100 is 10. Pretty simple. Let's do this bottom one here. Square root of 49x squared, 7x, and square root of 16 is 4. Plus, minus. It's that simple. And then these are called special cases, right? Because the parentheses are the same. So if you have x plus 5, x plus 5, for example, right? The middle term is not going to disappear. It's just going to be 5x twice, which is 10x, which is what you're going to see here. But these, you don't even have to treat them like special cases, because you can factor these using any other regular method you learned from me, and it works the same because it's a trinomial at the end of the day. Alright, so let's treat it the same so we don't have to think it's different. If the last number is positive, the signs are the same as the middle. So x on both sides with a minus minus. And now what times what gives you 16? 8 times 2, 4 times 4. Stop right there because 4 and 4 give you 8. Alright, same process here. Alright, but in this case, the number in the front is a number bigger than 1. So you're not just going to be able to put an x on both sides. Right? But it's the same process here. Because we know 4 is a perfect square and 9 is a perfect square, we can do the same thing. Square root of 4x squared is 2x. Square root of 9 is 3. And if the last number is positive, the signs are the same as the middle. So minus minus. So the only thing left to talk about on this page here, right, is writing that same answer we got as a square. So because the parentheses are identical, you can write that as 2x minus 3 to the second power. Now, is this incorrect? No, it's not incorrect. But what if it's multiple choice and they only show you this and you don't recognize it? So make sure you know that a parentheses with an exponent 2 gets expanded to a parentheses multiplied by the same parentheses. Alright, we're almost getting towards the end here. Actually, we should save this for the next video because now it's graphing. So hopefully this helps you so far. I'm going to stop this video, start recording the next video. Alright, let me know how it goes.